Okay. Third video for chapter, what is this, 6? Yeah. So to summarize on the impact of the omitted variable, it's going to tend to cause bias, but let's see here, anything else on that? No. But in a way that it's not really going to affect the t-scores. In fact, it can inflate them, it's hard to. That's why theory is so incredibly important. That's why he pushes this through the whole book. Even though it's a book about econometrics, he's saying, yeah, but you need the theory first in order to specify the regression properly. All right, what if you include a variable you didn't need? What if that? What if you also included people's height as one of the regressors in your explanation of people's grades? Then it's not going to be significant. It's going to probably lower your adjusted R-squared for reasons talked about in a previous chapter, but it doesn't cause any bias. And it kind of creates this slight incentive to include variables, to err on the side of including variables. Realistically speaking, you want to just make sure you put the right ones in. But it is a much worse mistake to not include a necessary variable than it is to include an irrelevant variable. Let's see what I have here. No bias. It increases the variances of the estimated coefficients, which will lower your t-scores, and it will lower your adjusted R-squared. So it will lower your t-scores of the other variables, because now you're asking the computer to, because remember, okay, let's go back to that. Remember, the computer trusts you. Remember, the computer thinks you know what you're doing. So you included people's height. So it tried its best to try to figure out, okay, all right, so height is important too to grades. Let me figure out how. Well, clearly that's going to impact on the estimates of the other variables, because it's now trying to attribute something to a variable that really had no impact whatsoever. It's pulling away from its focus on the other variables. You end up with lower t-scores, all right? A higher variance, and therefore lower t-scores. And that's it on a relevant variable. Now, the last part of this chapter is not something mathematical or something you're going to do on the computer, but it is absolutely fantastic. This starts on page, not there. Oh, that's a homework. Chapter 6. Oh, and there's lots of examples in the book too. That's really good. Okay. Here we go. Is this it? Section 6.4? No. Check out on page 166. Yeah, I've got that written down right there. Page 166, this listing right here. And this is going to be important for the rest of the semester. It's going to be part of exam answers, of study question answers. I'm sorry, not study question, of homework answers. What should guide you in determining which variables to include in a regression? Number one, guess what? How surprising? Theory. Now, is the variable's place in the equation unambiguous and theoretically sound? Does it make sense? All right, well, let's say you've got two things that make sense. Like I did. I measured it two different ways. And then I thought, well, it could be both at the same time. What if, well, then you pick on the basis, then you can pick on the basis of the t-score. Which one is significant in the expected direction? If there's two variables, here's a perfect example. The interest rate variable that I used in this. Guess what? There's more than one interest rate in the real world. So in that case, it's legitimate for me to say, I tried 3 different interest rate variables. These 2 didn't work. Now I need to have a good reason to try those specific variables. I believe these are 10-year Treasury bill rates. I can't remember now, on the assumption that firms that are borrowing to build physical capital are borrowing very long term, like when you buy a house and you get a 20-year mortgage. So these are long-term interest rates. And it worked. The first one I picked worked. And I didn't look anymore. But it would have been legitimate for me to say, you know, I know interest rates is right, or rather I'm convinced that interest rates is right, but I don't know which one. This one had the best t-score. Now the honest thing to do is to also point out that you tried other stuff that didn't work, but you can pick on the basis of the t-score. Now, what if, okay, but the t-scores, it theoretically makes sense, the t-scores work, what about the adjusted R-square? And this is like tiebreakers. All right, we got two teams finishing with the same record atop the AFC South. Who gets to go to the? Who is the winner of that division? Well, first tiebreaker. Well, actually, the first thing is your record. All right. Well, both teams had the same record. Okay. Number two, their head-to-head matchups. Well, their head-to-head matchups were exactly the same. They played each other twice, and one team won one and one team won the other. Okay, well, third, how did they do against other teams in the same division? You know, and you go down through the tiebreakers. That's what this is. These are kind of like tiebreakers. Okay, well, they all make theoretical sense. The T-scores are all significant. Okay, which one has the higher adjusted R-square? Which one has the higher adjusted R-square? And if you'll see in my case, it's actually the third one. So I'm thinking that's why I'm saying the third one I think makes the most sense. That everything makes sense theoretically. The T-scores are all significant in all three, but the last one has the highest adjusted R-square. So I'm thinking that's probably not by a lot, which is why, you know, one of the reasons why I reported all three, but not by a lot, but nevertheless. And then the last thing is, all right, we got decent adjusted R-squares on everything. Sorry, it's hard because it's not mirrored, or is it mirrored? No, it's not mirrored, so it's hard to figure out which way. Do the other variables' coefficients change significantly when the variable is added to the equation? If they do change significantly, it could be, like, let's say that, oh, I erased it all. Now, let's say that when you put SAT scores in, that hours, okay, you ran it without SAT scores, hours was a significant variable, then you put SAT scores in, hours stayed significant, but there was a big change in the coefficient. And you're like, oh, SAT score is important because hours was clearly absorbing something, or not, I shouldn't perhaps say clearly, but looks like hours was absorbing something that really SAT score was causing because there was a big change in the coefficient when I included it. And I actually did have some big changes in the coefficients for FOR, for the forecast. The forecast was what they expected before that quarter started. The surprise are things that happened during the quarter that they didn't expect. And in other words, they weren't consistent with the forecast. Notice how the forecast estimate goes from 21, I've crossed it out now, but I think you can read it, 21.96 to 17.93, I think it says, to 28.03. That's a pretty big change. Now look at the variable for the coefficient for surprise. It's basically 10 both times. And the coefficient for surprise 2 is, you know, right around 8. It didn't change much. And the PK changed a little bit, R changed, but look how much FOR changed. And what that suggests to me is that FOR needs those other two variables in there, that it is changing quite a bit every time you change which, by the way, that was the whole frickin' point of the paper, was that the surprise part is extremely important, that entrepreneurs will make big changes to their investment plans when they're like, oh crap, I thought we were going to earn so-and-so and we earned much less, and vice versa. Oh my God, things are going great. Let's double up on what we're doing. And so this suggests that the FOR variable, the forecast variable, is not sufficient by itself because, boy, it changes a lot when you put in other variables. All right. Now, those are the 4 important specification criteria. He then goes on in section 6.4 to have an absolutely fantastic section on what I like to call the ethical econometrician. And let me just, I jotted down some points here from the chapter. A weakness of econometrics, as he says here, is that a researcher can potentially manipulate data to produce almost any result. You have got to understand the weaknesses of this tool, all right? There are many things that you can, and remember, we don't want to use the word prove, but support, that make absolutely no theoretical sense, and that if you torture the data long enough, they will confess. If you change the formation, the specification long enough, all of a sudden something works. It's like, hey, that's what I meant all along. And so you don't want to, if you're going to be ethical, unfortunately, as in many places in life, there are rewards to not being ethical. I mean, if I had tried 10,000 different specifications of this and only these worked, which is not the case in this situation, fortunately. This was the only thing I tried. Then I'm kind of lying, really. Because most of the ways you could think of that relationship really didn't work. I happened to get lucky and got this one to work. Because after all, we're just taking a small sample here to try to figure out the way the real world works. And I got one little small sample to actually work, and I'm pretending like that's the only thing I did. And oh my God, what a great result this is. So, he says that rely on theory rather than statistical fit. Minimize the number of equations estimated. All right, so don't do 10,000 of these. And reveal in a footnote or an appendix all of the alternatives you tried. In my case, I put the alternatives right there in the chart with it. I've been doing that, I guess, since my second empirical paper years ago. I like to show all the results that I tried. Honestly, it's kind of interesting to see. Like I showed you, you wouldn't know that stuff about the... What if I had only reported that very last one? You wouldn't know, for example, that yeah, the estimate on the interest rate doesn't change much. That must be a fairly stable estimate. Likewise with P sub k, but boy, does FOR change a lot. You wouldn't know that if I only reported one. Right? Let's see. The unethical econometrician. So that's what the ethical econometrician does. Rely on theory, minimize the number of these you try to estimate, and try to reveal what things you tried that didn't work. Oh, it's a call from my parents. What time is it here? I will have to call them back. All right. Hopefully nothing bad. My mother fell and bruised her knee last Friday. I'm hoping they're just calling about something. If they call again, then I'll answer it. All right, the unethical econometrician. Yeah, you can go through and do 10,000 different estimations, and it kind of is the opposite of what I just said. Estimations of previous regressions are ignored. Data mining. You sit there and try all kinds of different stuff to find the one that works the best. Let's see, be careful. Academic journals often report what's going on. Okay. Yeah, I think that's good enough. So, anyway. So, that's chapter 6, a very important one for the rest of the semester, and a really interesting one. And next will be chapter 7.